compounds that create the glow of a firefly's belly, researchers were able to image cells deep in the brain of this marmoset for over a year. The blinking glow, or bioluminescence of fireflies, comes from a chemical reaction in their lower abdomens. The reaction varies slightly from species to species, but it's all based on an enzyme and a compound, coming together with a little oxygen and ATP. As the reaction goes forward, light is emitted. Scientists have been using variations on this reaction for decades to non-invasively observe biological processes in cells and small laboratory animals. But the light from these systems was not very bright and needed to be pretty close to the surface to be seen. Now researchers have engineered a modified luciferase-luciferin pair that glows up to 1,400 times brighter. Researchers used directed evolution to improve the enzyme's activity. They introduced randomly mutated versions of the enzyme into bacteria, then sprayed the bacterial colonies with a specialized substrate. The colonies that glowed the brightest were selected and mutated again. 21 generations later, the optimized enzyme-substrate pair glowed much brighter and was less toxic to cells. The brighter glow was due in part to the fact that the substrate was engineered to emit light in a different part of the spectrum. Redder light passes more easily through tissue, and the evolved enzyme was able to process the substrate faster, meaning more glowing reactions in less time. These improvements allowed the detection of cells in living animals much deeper inside the animal and with more precision. Using a camera sensitive to near-infrared light, researchers were able to detect single transplanted tumor cells in the lung of a living mouse, the equivalent of detecting a single firefly in a space the size of a high school gym. They were also able to monitor the activity of specific neurons in mice in reaction to novel environments. And they followed cells deep in the brain of the marmoset over the course of a year. In the future, this new imaging technique could help scientists learn about where stem cells end up, aid in monitoring the success of gene editing, and even track tumor growth in cancer patients.